but this is kind of the most important chart that we have. I've used this chart for probably 10 years because it's a good one. It feels a little kind of ironic now that virus is something that we all know and talk about. This is kind of a fake situation that would be in a lab. Viruses, fortunately, even COVID, does not spread this quickly. In a lab situation where you're intentionally growing the virus, it tends to triple on a daily basis. And that is not the case in real life. I think the infection rate in Ontario has been doubling about every 6 days and or every 5 days, and I think it just switched to every 6 days. So what that would be saying is that your actual change would be more like the doubling curve, but your time period isn't days, it's every 5 or 6 days. Still though, exponential growth is crazy, and you'll see that when we get into the graphing of it next week, and why the increase is so quick around the world here. But yeah, that's the basis of the math that you have to be able to do for it. This you might have forgotten from grade 11 math. Every single nonlinear relationship uses the exact same equation, but in grade 11 math, I think you focus more on finance, where you would say, I have this much amount of money, I have this interest rate, and this amount of time period. If you look at this formula, it's the same thing. Your first value is just what you start with. So if you had $1,000, you would have 1,000 out front here. In this case, you have a 1 because there's just one kid that starts helping people. This is your growth rate because it's tripling. So for both the virus and this tree diagram, it's a tripling pattern. So that's your rate of change. If you had had an interest rate of 5%, you would do 0.05 if you just wanted the interest, or 1.05 if you wanted the interest plus the original principal. Tax in Canada is 13%. So we would do a change rate of 1.13 if you're doing the tax on top of your purchase, or 0.13 if you're only doing the tax. So I hope that just helps remind you that your rate of change is just what you did in grade 11 math. It's just putting whatever that change value is in the brackets, and then the exponent could be an x for the variable. I think often it's a t. So in physics and in finance, it's a t or an n to go and show time or the number of time periods. It does not matter. Just I use an x because that's what we're going to see on the graph when you type it in, y versus the x. So then from there, the rest of the sheet I hope is straightforward. Notice that when you flip it over, this is your tripling pattern, but that is not enough when it comes to knowing how many people were helped in total, or what are the total number of people that have been infected. So if I use the COVID virus example, this here would only show who is being infected on the next day. But we want to know a cumulative total, so also how many people are being infected in total. So fine to say that New York State or Ontario has 729 new cases today, but we want to know how many cases did they have before that too. And so if you were doing this on a spreadsheet, you would just type in a formula of equal to sum, and then go and highlight all of these different values that are here. In this case, it's a little bit easier. We can just go through and take the number that was before and then add the new total of 729 to it to be able to get the new cumulative total. And then from there, you got a couple of questions to answer. You can check the solutions here if you're not sure. And then I would say the most important technology thing is being able to actually graph these lines. This should not be new. You should have done this all in grade 10 and 11, so I hope it's a review. But again, in this course, use technology all the time. I love the Desmos calculator, but if you have a graphing calculator or some other program you want to use instead, you could do that. But if you go to this website and type in each of these equations, what I like about this is that it gives you multiple equations at once. And so just looking down here at the graph, it color codes. So the first equation you put in is the red one. So that's our standard linear equation, y is equal to x. And then you can see my parabola going to equation 4. So your standard parabola, y is equal to x squared. And then what we will mainly deal with when it comes to rates of change is the equation like y is equal to 2 to the exponent x, which is a doubling curve or a tripling curve with the 3 to the exponent x, or any value we put in. So we could put in a COVID growth rate of, say, 20% per day, or we could do a student interest rate of 6% a day, and then that would be y is equal to 1.06 to the exponent x. It does not matter what your equation is or the change rate. Every single value will go through the 0.01. It never gets down to 0. It gets really close, which is why you don't see the line there. But then the part we see the most in the news right now is the huge exponential increase. So the fact that you could start at 1 and then you get to 2, 4, 8, or in this case of a tripling graph, it increasing at an even faster rate. So that is the basics of nonlinear. And being able to deal with the graphing side, and then starting with the data side, looking at the pattern and then how to best show it with exponents too.